Okay, we're going to jump back to Chapter 3, Section 2. We're going to solve systems of equations using linear elimination. This is used to find the intersection point of two lines. Remember, two lines that intersect are going to have only one intersection point, and that is what our solution is using linear elimination, also known as linear combination. Before you even start, you have to make sure that your equations are lined up. Make sure your x's are in one area and make sure your y's are on top of each other and your your constants. Okay, in order to do that, you're just going to add and subtract and manipulate the equation so that they look like this. Your a, b, and c are your coefficients and constant. All right, the goal is to examine the coefficients of the variables, determine which variable is easier to eliminating by finding the least common multiple of each variable. The coefficients must be opposites of each other when you add them so that they can cancel out. So let's talk about the terminology in all of this. What is a coefficient? First of all, a coefficient is the number in front of the variable. A variable is the actual letter used that represents a number. LCM, least common multiple. We like to confuse this one with greatest common factor. Okay, least common multiple, you have to think of multiples of a number. When you learned multiples of a number, you learned multiples of 2 are 2, 4, 6, 8, 10, 12. Those are multiples. Okay, 6 times 1 is 6, 12, 6 times 3 is 18, 24, 30. Those are multiples of 2 and 6. A least common multiple is the smallest common number in both of those. So we would say 6 is the least common multiple of 2 and 6. And then we have to think, okay, what are opposites? Opposites are two numbers. When you add them together, they cancel out. So if you have -2 plus 2, those are opposites. You get 0. -3 plus 3 or 3 plus -3, whatever it might be, they're opposites. Here are the steps to solve. I always give steps to make sure that if you ever have to solve without any help, you can follow the steps and have an idea of how to solve the problem. I'll go ahead and use these steps for the first one. Step 1, calculate the least common multiple of the x's, or the x and y coefficients, are step 1 and 2. So what we're talking about here is the coefficients. Okay, so the coefficient for the x's is 3 and 2. The least common multiple of 3 and 2, well, we have 3, 6, 9, 12, 15, 2, 4, 6, 8, 10, 6. Both of those least common multiples 6. For the y's, 4 and 3 is 12. Now I have to choose one of those two and manipulate the equation to make so they're opposites of each other. If you remember, opposites are positive and negative. So I'm going to pick the x coefficients and I'm going to try to manipulate the equations so that I have a positive 6 and a negative 6. How do I make or manipulate the first equation to get so that the leading coefficient or the x coefficient is positive 6? Well, in order to do that, I have to multiply this entire equation by 2. Why 2? Because when I distribute that 2, I go ahead and I get positive 6. 2 times 3 is positive 6. 2 times 4 is 8. So I get 8y equals 2. So I was able to get a positive 6 for the coefficient of the x. How do I get a negative 6 for the second equation? For this equation, I need a negative 6. What am I going to do? What do I have to multiply the entire equation by to get a negative 6? Negative 3. When I distribute that, now negative 3 times 2x gives me negative 6x. Negative 3 times 3y is negative 9y. Negative 3 times 7 is negative 21. And the reason I did that is because now the next step is we're going to add the equations together so that the coefficients cancel out. The x coefficient cancel out. 6x minus 6x cancels. 9y minus 9y is negative y. 2 minus 21 is negative 19. That means y is 19. Now I'm going to take that 19 and plug it into one of the two original equations that I was given and solve for x. So let's just say we take the first equation. So I have 3x plus 4 times y, but instead of y, I'm going to replace the y with the 19 that I just found. 3x plus 76 equals 1, subtract 76. So I have 3x equals negative 75, divide by 3, x equals negative 25. My point of intersection, remember the goal of all of this, the reason we calculate all this algebra is to find the point of intersection of two lines. Well, the x value is negative 25 and the y value is 19. We call that the point of intersection or the solution. Now, if you want to check your answer, go ahead and graph it. Let's look at our graph. The first problem was 3x plus 4y equals 1. So if I type in 3x plus 4y equals 1, there's that line. And then the second line I had was 2x plus 3y equals 7. Oops. Okay, and there we have it. Now, if we were to go ahead and put our cursor over that intersection up here, we would see that it's negative 25, 19, which is exactly what we had. So you can use Desmos to check your answer if needed. Let's try another one. So step 1, I'm going to calculate the least common multiple of the x's and the least common multiple of the y's. Well, we have for the x's 2 and 6. Least common multiple is 6. For the y's, I have 3 and 9. Least common multiple is 9. So I can choose either one. I'll choose x again because this is already a positive 6. So all I have to do is make that top a negative 6. So what do I have to multiply that equation to make so that the x coefficient is negative 6. Multiply it by negative 3, because negative 3 times 2x gives me negative 6x. Negative 3 times negative 3y is positive 9y. Negative 3 times 6 is negative 18. Go ahead and add those two equations. 6x minus 6x cancels. I have 0. Negative 9y plus 9y also cancels, and I have 0. 9 minus 18 is negative 9. So I have 0 equals negative 9, which is a false statement. So that tells me something. What does that tell me about these two equations or these two lines? It tells me that these lines never intersect. Two lines that never intersect are known as parallel lines, meaning there is no solution or no intersection point. Okay? Sometimes when you solve these, you're going to come up with something that looks like this. 4y minus 6, or excuse me, let me change that. 4x minus 6y equals 12, and negative 4x plus 6y equals negative 12. If you ever have something that looks like this when you add them and everything cancels out and you're just left with 0 equals 0, that means you have two lines that are exactly the same. They have the same slope and they have the same y-intercept. And since that's the case here, what does that tell me about the two lines? How many times do they intersect if they're the exact same line? They intersect all the time. There's infinitely many intersection points or all possible solutions. There are so many ways you could say that. X is in the set of all real numbers, all possible solutions. Infinity, negative infinity to positive infinity, okay? If it's a true statement. If it's a false statement, that means there's parallel lines, there's no solution. Let's try one more example. First step, find the least common multiple of the x's and the least common multiple of the y's. 2 and 3 is 6. 1 and 4 is 4. Now, here's a trick for this one. I'm going to go ahead and choose the y's because I want positive and negative 4. And the reason I'm going to choose the y's is because this is already positive 4. All I have to do is make that first equation negative 4. In this case, if you choose the x coefficients, you're going to have to multiply. You're going to make this one positive 6 and this one negative 6. For the y's, I only have to change one equation, which saves me time. So I'm going to multiply the top equation by 4 and distribute. So I have 8x minus 4y equals negative 4. Now, I don't even have to change this one. I can go ahead and add the two equations. 3x plus 8x is 11x. This one cancels, and I'm left with 11. Divide both sides by 11 to find the value for your x, which is 1. Once you have the x value, you can choose either original equation, I'll choose this one, and plug in 1 for your x value to find y. So I have 2 times 1 minus y equals negative 1. 2 minus y equals negative 1. Subtract 2. Negative y equals negative 3. Divide by negative 1. Y equals 3. So my point of intersection for these two lines is x is 1 and y is 3. X comes first, then y. It's an ordered pair, also known as the POI, or point of intersection. Let's go ahead and graph these just to double check them. So I'm going to delete my other two lines. First one is 2x minus y equals negative 1. So I have 2x minus y. And the second one is 2x minus y equals, negative 1. I'll have to add a negative. 3x plus 4y equals 15. 3x plus 4y equals 15. All right, let's add a negative right here. Okay, point of intersection. Did I get those right? 3x plus 4y equals 15. And 2x minus y equals negative 1. All right, let's see what we got here. Point of intersection. 1, 3. And right there it is. And that checks out with what we had. Right here.